Chapter 5, Lesson 1, Exponents in Scientific Notation. Go ahead and pause here and take the notes over exponential rules. All right, so the first thing we're going to do is examples of the product rule, which says if I have the same base and they're being multiplied together, I can add the exponents. And so on the first one, I look to make sure, okay, are they the same base? Yes, they're both 3. And so then what I'm going to do is I'm going to add their exponents. And so this answer would be 3 to the 4th power. On this one, anytime a number stands alone, we give it an exponent of 1. And so the only ones that I can combine their exponents are the x's. So I know that it's going to become x to the 6 plus 1 power. And now also I need to combine the 3 and the 5. Well, there's not a symbol here, so I know that that's a multiply. And I'm not trying to add their bases or anything or their exponents because they're not the same base. So I'm literally just going to multiply the coefficients to get 15. And so then my final answer will be 15x to the 7th. The same thing on this one, I'm going to give x a 1 because it stands alone. So I know I'm going to have x to the 3 plus 1 power. Then I have these p's. So I'm going to have p to the 2 plus 10 power. And then all that's left are these coefficients here, which I'm going to go ahead and multiply, which is negative 9.6, possibly. Where's my calculator? There it is. Negative 2.4 times 4. Yeah, I was right. Negative 9.6. So then my final answer is negative 9.6, x to the 4th, p to the 12th. For this example, anytime you have a base to the 0 power, it's 1. So 7 to the 0 power is 1. All of this is included here because it's in parentheses. So the whole parentheses is to the 0 power. So that answer is 1. This one we have to be careful because there's no parentheses. So it's only x to the 0 power. So only that part becomes 1. And then I'm left with 3 times 1, which is 3. On the quotient rule, these should actually be written in fractions. And so this should be x divided by 7, or x to the 7th divided by x to the 4th. Why are those so light? Okay. So when I reduce those, I'm subtracting. So x to the 7 minus 4. So that's x to the 3rd. This one is 5 to the 8th over 5 squared. And I'm subtracting them. So it becomes 5 to the 6th. This one over here is hard to read. It's 20x to the 6th over 4x to the 5th. So I'm going to subtract these. So that becomes x to the 1st. And now looking at these, it's just 20 divided by 4, which is 5. The next one is 12y10z7 over 14y8z7. So when I do like bases, these two are just going to actually cancel each other out. Then I'm also going to have y to the 2nd up on the top. And then I'm going to divide these in my calculator, which I know is not going to give me a whole number. That's why I left it in fraction form. And it reduces to 6/7. So the final answer for that one would be 6y squared on the top and then over 7. Also, we can't have negative exponents. So what we're going to do is we're going to flip them in a fraction. We're only going to flip the ones that are negative and create those into a fraction. If it doesn't apply to all the bases, then we won't switch them all. So number 1 is a negative. So I'm going to flip it to the bottom to make it a positive. The next one, I'm going to flip it to the bottom also to make it a positive, but it only applies to the exponent, not to the base. On number 3, only the x to the 3rd is negative. The 2 is not, so the 2 should not be flipped. So you can either write it as 2 and then 1 over x to the 3rd, or you can write it as 2 on the top and x to the 3rd on the bottom. This is how I prefer you do it, but I think the book might give you the answer like that. I would prefer you do it the second way, like in the circle, because eventually we're going to be reducing exponents in big, long lines, and it just makes more sense to ask yourself, should something stay or flip? So on number 4 here, we have m to the 5th over m to the 15th. This kind of goes back to our subtraction rules. So I'm going to subtract away 5 from each of these. So that would leave me with nothing on the top, so just a 1, and then m to the 10 on bottom. On this last one, they're both going to get flipped. So I'm going to have 2 to the positive 1 plus 3 to the positive second. And the book is probably going to want you to simplify that. So 3 squared is 9. So I have 1 over 2 plus 9, which is 11. So here are some examples of all the rules combined. So the first one, 3 times 4 to the 3rd power. 4 to the 3rd. Can't type it in. 3 times 4 to the 3rd. 192. 8 to the 0 is 1. This one I can only add the x's. So that would be x to the 6th. And then I multiply 4 and 2, which is 8. This one I'm just going to add the exponents. So it's x to the 8th. This one I'm going to multiply the coefficients and then add the exponents. So it's 4x to the 5th. On number 8, anything to the 0 power is 1, but it's also a negative. On number 9, this is going to be our distributing rule. So when the number is outside, just like we did before, we're going to multiply. So this becomes y to the 12th. Number 10, I'm going to give this y a 1. So it would become y to the 8th, or x to the 8th, sorry, not y. And then y to the 4th. This one I'm going to reduce them, so it becomes 6 squared, which is 36. This one I'm going to reduce them both by 4, but the 7 is on the bottom, so that's where the 3 should be. This one I'm going to reduce them, so x to the 3rd stays up top. And then 6 divided by 2 is 3. This one I'm going to take away 2 from each, so x to the 3rd on top. And 8 divided by 4 is 2. Okay, go ahead and pause and take these notes. And pause and take these notes. Okay, on these examples, we're being asked to change the standard form into scientific notation or scientific notation into standard. So on this first one, I need to make it a decimal between 1 and 10, which would be 7.3 times 10 to the, and then I count 1, 2, 3, 4, 5 to make it original. And it was to the right, so I give it a positive 5. Number 2, I need to make this into a decimal between 1 and 10. So 1.04 would be the decimal I could make. And then I count 1, 2, 3, 4, 5, 6 to get it back to the original. And I went to the left, so it would be negative 6 power. On number 3, it is in scientific notation. It's like 4.0. And I need to move it back into standard. And it says to go negative 4, so left 4. 1, 2, 3, 4. And I fill these spaces in with zeros. So that would be the answer. Number 4, I start with 1.5, and it says move it 7 places positive. So 1, 2, 3, 4, 5, 6, 7. Fill those in with zeros. And I get 15 million.